Hey everyone, my name is Scott Pecorello. I am a co-founder and CEO at Weather Optics, and welcome to our new podcast series called Beyond the Forecast. This podcast will cover the latest in weather, climate, and risk technology, introducing new and innovative products that our team is developing at Weather Optics, along with how the industry is evolving as a whole. We'll also bring in outside experts, some of our key partners and customers, and special guests along the way. Today's episode starts with a big announcement. The team at Weather Optics has developed our own proprietary nowcast model called HYPERR, the Hyperlocal Enhanced Rapid Refresh model, that drastically improves the accuracy of our real-time and short-term weather forecasts. In just a second, we're going to talk with two of my other co-founders on what this means for our customers, the industry as a whole, and how quickly this technology is advancing. So let's dive into it. I am joined here by Josh Feldman, who is our head of meteorology, and Jared Goldberg, who's our head of data. Welcome to the first episode of our podcast. Josh, let's kick it off with you. High level, could you talk about what's going on in the industry right now with AI and why there's been all this buzz around weather modeling and AI advancements involving weather modeling?
Yeah, sure. So around the end of 2022, NVIDIA released their ForecastNet. It's an AI that predicts a 10-day weather forecast in just a few seconds, and you can run it on your laptop. And then shortly thereafter, Huawei, the phone manufacturer from China that we might know, they released their own version, Pengy Weather, and then shortly thereafter, Google released theirs called GraphCast. And since they've released it in just the past year or so, they've already released new iterations. And just the last month or so, NVIDIA has released a climate model. And these have gotten a lot of hype because you can run it on your own computer. And typically, a weather forecast takes a supercomputer the size of a city block, and it takes a few hours, whereas these do it in a few seconds. And recent studies have found that they're almost, if not as accurate as the leading global weather forecasts by the European model. So within the past 2 years, I'd say things have really taken off and the media's ran away with it.
That makes sense. And so, what would you say are the main advantages? I know it can be run faster or cheaper. What else can these AI run models do in terms of advantages to either forecast accuracy or the industry as a whole?
Right. So besides being able to run something super fast, that's probably the main advantage. The other is that you can make something super targeted. And this goes back at least 10 years where you could sort of target a model for, let's say, convection, thunderstorms, severe weather over a small area that you're concerned about. There are solutions today that exist, but now you can train a model that, again, you can run on your laptop that's tailored specifically to that solution, and it need not be restricted to thunderstorms. It could just be your own area of interest. In fact, that's how a lot of these, that's how NVIDIA's model, for example, they're starting on a small area, and once they get that right, they can expand it on the globe, but there's really no limit to what you can forecast.
Yeah, that's pretty wild. Now let's talk about HYPERR. And if you could just give us, maybe a 45-second overview of what HYPERR does, why it's important, and what it can do for our customers.
A lot of people who are involved in this space have a deep fundamental understanding of these physics-based models that are sort of the root of modern quantitative forecasting. But we also understand that these models have intrinsic biases and patterns, patterns of issues essentially that are intrinsic to their behavior. And so essentially what we've done is using the latest in AI technology and computer vision, we're able to take a look at the most cutting edge, physics-based forecasts and exploit these biases and make enhancements on top of what these models are already doing. And using this understanding and comparing it to these ground truth impacts, we're able to make improvements of, up to 50% in terms of error reduction.
Got it. So basically, what we're doing, right, is we're looking at live radar, we're looking at station data, and we're looking at kind of this short-term modeling that already exists. And then we're constantly checking to make sure that that model is giving a decent depiction of what's happening. And if it's not, we are correcting that to make a more accurate forecast. Is essentially, if you had to summarize, that's kind of what we're doing with HYPERR, right?
Absolutely.
Makes sense. And when we talk about accuracy improvements and why this is important, right? Like, what does HYPERR actually bring to the industry? Maybe we could start with Jared. How much are we able to now improve our forecast accuracy for our customers?
Yeah. So I guess the short answer until we dive deeper is we're seeing up to 50% error reduction. So if you take the error of these existing models, which is something like this, and you take the error of HYPERR system, which is something like this, and you compare it as a percentage of error that we start with, we're making about 50% reductions. And why this becomes important is a lot of times when it comes to convective events like pop-up thunderstorms, which can be pretty extreme in terms of the amount of rain that's falling in a relatively short period, what we're seeing is existing weather models, they're a little late to the jump, right? And a lot of times they can't really pick up fast enough what's happening in the atmosphere. And so where HYPERR is going to change the game is in that 6-hour out window when we already have an understanding that there could be some sort of impact, but we're not exactly sure where that impact's going to be and when it's going to happen. We're going to be delivering really hyper-local, really granular forecasts that will allow our customers to save important shipments from being disrupted from weather or make preparations earlier on for different locations that are going to see issues arising.
Yep, that makes sense. And I think there's sort of like this gap, right, Josh, like where basically we have good real-time data. Like we have radar data where someone could see what's happening right now. And then we also have these short-term high-resolution models like the HYPERR, but kind of connecting the two, sometimes they're off from each other, right? Like
Right.
the initialization of the HYPERR could be different than what's actually happening. And so in some ways, HYPERR is almost bridging some of that gap, right? And allowing our customers and the industry in general to get a better idea of like what is happening in real time and in the immediate short term, to Jared's point, to do things like show a pop-up thunderstorm that might not exist in the model but exists on radar, show an area of higher wind gusts, show a period of heavier rainfall, stuff like that. Is that a reasonable way to kind of think about some of the benefits there?
Yeah, definitely. But it actually goes back to what I was saying before about how it takes an hour or two for a supercomputer to make a weather forecast. So the HYPPR might initialize a thunderstorm in its early growth stage. Hour later, it doesn't have any new thunderstorms, and maybe it doesn't have that thunderstorm represented very well. It takes a few hours to sort of spin things up. And so what we do is we bridge that gap. And so we'll get this a lot. Customer will ask, hey, if a thunderstorm were to pop up in the next hour or two after I checked your forecast, would you guys be able to pick up on that? And the HYPPR can't do that. It can to some extent, depending on the features, but just a regular pop-up thunderstorm, I wouldn't bet my money on it. But that's exactly what HYPERR is intended to do.
Yep, that makes sense. And I'm trying to think of the benefits to our customer base. Obviously, we mostly sell into supply chain, transportation, insurance, outdoor events. Those are kind of like our focus, emergency management. And so I think by having HYPERR be the weather engine to all of our risk products, the example that we used earlier where a trucking company can now see a thunderstorm that maybe they wouldn't have seen before, or a truck that's at risk of tipping over on a highway due to high winds, that might miss that initial forecast, that initial call, will now be able to tell that's happening. For outdoor events and venues, right? Like getting a better sense of where severe thunderstorms are going, where there's going to be lightning, things of that nature, where it's like, these companies need really granular, really accurate forecasts, and misses in those forecasts are super costly, to the operations themselves, and also for from a safety perspective for truck drivers, for people who are going to concerts or to sporting events, right? Like this data, and having a really good understanding within that 0 through 6 hour period is crucial, and that's a lot of what HYPERR is providing. Jared, do you want to go through kind of how we developed the model, how we created HYPERR, what really goes into it to make it so much more accurate than maybe what's on the market today?
Yeah, so there's really two pieces happening. So the first piece involves leveraging radar data itself, which, all of the sort of baseline refresh models that are used are all based on mathematical understandings of the atmosphere, essentially. But by using live radar, which, as you said, is essentially a very close proxy to what is actually happening by looking at that radar reflectivity, that's how we're able to produce these nice, even shorter term in terms of timestamps and more granular in terms of hyperlocal. That's the first piece that goes into it, is this radar data. The second piece, which took a lot of time in terms of the getting the model and tweaking the model, has to do with exploiting those weaknesses in the physics models themselves. And this is more for those 5-6 hours in advance sort of forecasts. We see trends essentially in comparing what forecasts are calling out and what's recently actually happened. And this is where the weather station data comes in itself as well. And essentially we have an understanding of when trends are going a certain direction, it implies that the model is going to be wrong in a certain direction. And so by pointing sort of these AI eyes at these different trends that we've done a lot of pre-processing to identify, that's how we're making improvements in that short-term modeling in the hours phase in order to make these improvements.
Yeah, that makes perfect sense. And Josh, we've seen like recent events over the last, I don't know, couple months and over the last couple of years where there have been extreme weather situations that, as good as the HYPERR is, as good as the high-res NAM is, right? They miss or they misplace like critical weather variables. If it's heavy rainfall, if it's flooding, if it's high winds, and even those like slight shifts in forecast, right? Where you think one town's going to get hit and it's another town, or no one gets hit and there's over preparation. There are great examples now that we have of HYPERR sort of being able to do that. Do you have any on hand that we can go through?
Yeah, let me show you one. Absolutely. I may share my screen. Here we go. Yeah, so this is an example that hits close to home to me. So I'm in Pittsburgh. We're off to our wettest start of the year. This is going to be the wettest April. And on the evening of April 2nd to April 3rd, there was a sort of a culmination of flooding. You might have seen the pictures on social media of the Ohio River rising up into downtown Pittsburgh, submerging a highway. That's from these last few rounds of showers and thunderstorms. And what you see on the left here, this is what was observed from the radar. And I want to point your eye out both to the focus here over the river and over here in East Central Ohio. You can see that HYPERR picked up on this both here in East Central Ohio. There's about 1 inch of rain that did prompt flood warnings. Now, normally 1 inch of rain wouldn't matter much, but if you've got a saturated ground, you're going to flood. This is within the span of 6 hours. And then again here over, I believe this is the Ohio River, where a lot of flooding was also observed. Now, it's not that over here on the right, the HYPERR was a bad forecast, but it completely missed out on this area of East Central Ohio that did end up flooding, and it was misplaced from the Ohio River where flooding actually did happen. And then finally, the HYPERR has a wet bias. You can see there's some 2 to 3 inch precipitation amounts. Not that that's not a lot, but we didn't quite need as much to get to flooding, and what we have is much closer to what was actually observed.
And so those tiny differences, Josh, right? Like, even a couple miles where heavy rain is predicted to be somewhere that it ends up not being. I mean, looking back at that event, right? Like it made a huge difference, the accuracy of being able to pinpoint exactly where that's happening.
Yeah, and unfortunately, it made a difference in the worst kind of way, because all that rain fell directly on the river, leading to quite rapid rises. So that the next day, Granted, a lot of those pictures were from downstream, but in Pittsburgh itself, right away we saw river rises, and for emergency responders, an hour could be a long time for water to rush away from wherever it had fallen into where it actually pooled up. It really does matter.
And I think what's so unique about weather optics, obviously, like we're focused on taking raw weather data, translating it into risk scores, actionable insights through looking at all of these different variables. And so having a more accurate depiction on the weather modeling side of things and having a more accurate hyperlocal view of where, even if it's an inch of rainfall, right? We're then enhancing and solving that problem even more by producing things like our flood index. So to your point, right, you were like, an inch of rain doesn't sound like a lot, but there was devastating flooding there. And so it's great that now HYPERR as a model can better identify where that's happening, but it's even better that our flood index can now take that into account, the recent rainfall, the soil moisture, and give a really full story and a much better warning to certain areas that, hey, this inch of rain is actually going to do a lot of damage. So I think having HYPERR as the engine feeding into what we do today is just going to be massive for our client base and for future customers of ours. Jared, when we look at the bigger picture, right, it's great to see a couple case studies. We have many case studies, I think, using HYPERR, but when we look at the overall accuracy improvement, could you talk us through that and what we've seen?
Yeah, so we've done quite a bit of back testing to ensure that the improvements that we're making happened what we'll call out of sample, right? So not events that were trained in the model, but events that we deployed the model in essentially real time, saying, okay, here's the current forecast. We're going to apply our model, collect them before the thunderstorm starts or before the event starts, and then collect millions of data points basically by doing that. And so I can show you some results when it comes to precipitation, about how we're actually going to be making improvements. So this is predictions for HYPERR compared to the HYPERR, and this is specifically for inches of precipitation, essentially. So what we're seeing is this red bar is the amount of forecast error that the HYPERR calls out. And what we're seeing is 6, 5, all the way through 1 hour out. We're seeing significant improvements. By improvements, I mean reduction in error, obviously, because error means wrongness. So we're reducing the amount of wrongness in these models, and we can see 6 hours out, we're making over 50% improvement in this error. And this improvement stays, relatively consistent in terms of significant difference as we approach real time. And again, this isn't based on a single thunderstorm event or a handful of thunderstorm events. This is based on millions of individual forecasts for different locations that were affected by precipitation events historically.
So that's for precipitation specifically. And also, do we have any studies for the wind gusts that we can show?
Yep, we do. So we've done a similar analysis for all of the variables that we essentially are enhancing. So here's the same idea, but this time with wind gusts, right? So again, the red bar represents the error for the HYPERR. The blue bar represents the weather optics HYPERR model error. And as we're seeing, again, real consistent across the board from 6 hours out to basically real time, that shows that the HYPERR system is making significant improvements in terms of reductions of error when we compare it to some of the more advanced, rapid refresh models that exist.
And Josh, I think, kind of zooming out even more, there's sort of this misconception that now we're heading into spring and summer. And so, transportation companies maybe don't need to worry as much about the weather or retailers or other supply chain organizations, right? When in fact, a lot of accidents that happen are actually due to these pop-up events, whether it's a squall, a severe thunderstorm, something that is small and kind of hard to predict. Can you speak to some of the risks that could happen in the spring and summer months as we approach severe weather season, as we approach hurricane season, and how HYPERR could potentially improve those sort of forecasts for businesses?
Right. I'll sort of speak to two situations where in the spring and summer the risk is not quite realized by most of the public. So one discovery that was quite surprising to us when we're developing our crash index, we had pulled in millions of observations of driving history, and we paired it with the weather. What we noticed was a lot of accidents actually occurred during and just after a heavy rain event. And maybe that heavy rain event was around an hour or so, which lines up with a spring or summer thunderstorm. And the reason that might be is there's very poor visibility, and there's a lot of debris on the road from severe thunderstorms. And B, the roads are still wet. Hydroplaning is a significant concern, and that's especially the case in climates where rain isn't so common, or around densely populated areas where there's a lot of oil on the road, and so you have oil that floats to the top and you spin out. The other concern, of course, is severe thunderstorms. That isn't something that you can predict well in advance. That's something that HYPERR is specifically attuned for. When you're driving and if you're going down the road, you see a storm out ahead of you, you don't really know in advance what risks it might pose. But with weather optics and with HYPERR, we might be able to warn you now of your truck perhaps rolling over because there's strong winds in that thunderstorm, or perhaps there's a flood and we might need to divert you. And if you are not aware of a flood, you might lose your vehicle when you drive into a flood and you don't see it ahead of you. So I would say severe thunderstorms and any kind of hydroplaning risk are two main ways that HYPERR would help you during the summer months.
That makes sense. Yep. And weather optics is all about translating weather data, right? We have these unique risk scores, we have right route, we have delay times, tipping index. We produce data and insights that allow basically businesses to act more quickly and more efficiently on weather. And so, Jared, this question is for you. How is HYPERR going to directly impact all of the risk scores that we have and all of the unique kind of translated products that we have? How is that going to change as HYPERR powers basically, eventually all of our products?
Yeah, the short answer is that our accuracy is going to, make significant improvements. And to the point that you mentioned, we take a lot into account when it comes to these risk scores. So, for example, for our road conditions index, we take into account non-weather factors like the slope of the road and also where that place is located, because a place like Boston handles snow better than a place like Atlanta or somewhere like Seattle. And even though this is a really important part of the modeling when it comes to calling out these impact insights, obviously, and we discuss this a lot, the weather is just as important and more important than any other non-weather factor, essentially. So the non-weather factors are essential to making these predictions, but on the other hand, obviously the weather that's occurring is the biggest factor that contributes to these risk scores. And so what we're going to see is improvements within the 6-hour window when it comes to just the straight up accuracy of these scores, but also things like the false alarm rate, because knowing, reducing the amount of times that we give our clients a false alarm is also going to allow them not to, as you mentioned, spend extraneous resources on events that don't actually come to fruition. So that's another important piece to come to mind. It's not only about accuracy, but it's about the false alarm rate. It's about the true positive rate, the false positive rate. And all of these are going to make improvements when it comes to the short-term forecasting. And it's just going to be great to know that within that shorter window, once we have that heads up that, hey, we're we know something's coming. Now, when it's time to really take action or really, batten up the hatches when it's really extreme weather, we're going to know exactly when and where those impacts are going to happen.
Absolutely. And as we wrap up here, I want to talk a little bit about what's next in terms of weather optics and our modeling. I think, we've talked a lot about this short term and this exciting announcement with HYPERR. I also want to talk about the long term, right? And how AI might influence our modeling into the future. And so I think for us, it's a lot about focusing on the medium and long range and making sure that not only are the 0 to 6 hours going to be accurate, but 6 to 72 to 84, all the way out to, a week in advance is going to be more and more accurate over time. And the fact that we're seeing these AI models already match some of what NOAA and these other government agencies are producing, I think is really encouraging for the industry as a whole. And I think it's something that as an innovative team that's super nimble and in a position to take advantage of this, I think it's going to do a lot for us and our accuracy, and then also our ability to help our clients, better predict how their operations are going to be impacted and what they can do to prevent losses and improve safety. But as a final note, would love to hear from each of you kind of, the future of weather optics in terms of modeling and where we think things are headed. So Josh, we could start off with you, and then Jared, you can close us out.
Well, first off, over the summer, we do plan on upgrading our medium and long-term weather modeling with a new data source. So we're hoping that this ensemble of most of the world's data will give us a more consistently accurate forecast. And then on the long-term horizon, we do plan on actually implementing one of these AI products from, be it Google or ForecastNet, whoever. We're going to test them, and we hope to have something in-house one day.
Absolutely. Jared?
Yeah, I mean, what we're seeing is really an exponential increase in how powerful these AI models are getting. And I think the general public has been made aware of it from models such as ChatGPT and these generative AI, frameworks that are really quickly iterating in terms of seeing, hey, version 3 of that model was significantly better than version 2. And we're seeing it being able to be extrapolated into different tasks, right? We know you can type in prompts and get prompts in response. You can type in prompts and get images and get videos. And so what we're seeing is these infrastructures are so powerful that they can be applied to a variety of domains. And so I think it's really only a matter of time, and we're already seeing it start to happen, where some of these more advanced infrastructures are getting applied into this space. And as Josh mentioned, as the amount of compute becomes more widely available and as computers get stronger and cheaper and so forth, we're looking forward to hosting our own in-house model where sort of takes it a step further than HYPERR in terms of, instead of just adjusting, really generating what we believe are going to be the most accurate predictions, but completely from the source in terms of mixing AI along with the physical equations.
It's definitely an exciting time to be in the weather space, and an exciting time for weather optics as well. So on that note, we will close out our first episode of Beyond the Forecast. Thank you both for joining me, and to our audience, we will see you next time.